Hi, so for this one, it says an annual effective rate of this. Each of these are equal to x, which means that we have to set both of these equal to each other. So the accumulated value, okay, at the end of n years, so 10.9 effective is paying 21.80 per year, right? So this would be along the lines of 21.80 times 1.109 to the n minus 1 over 0.109, right? So if we were to simplify this, we would get 21.8 divided by 0.109, which is 200. Now, another thing here is that the present value of perpetuity-immediate paying this amount at each n year period. So what would that mean is that would mean that by each n year period, it would represent this amount discounted back n periods, and the next period would be 2n, and so on and so forth. So we would have to compress this by doing the first term minus over 1 minus common ratio. So what we're going to get is we're going to get the first term of v to the n over 1 minus the common ratio of v to the n. So now, yeah, so we have to get this all together, and we're going to set it equal to this equation that we have here, right? So let's rewrite it here. So this is 1 over 1.109 to the n over 1 minus 1 over 1.109 to the n, right? So now let's simplify this. So if I were to put this together, it would be so then it would be 1.109 to the n minus 1 over 0.09 to the n. So if I put this in here and if I were to flip it over, we would get rid of this amount. Then we would end up with 19208 over 1.109 to the n minus 1. So that's going to equal this amount here with the 200, this amount 109 to the n of minus 1, right? So we see a similarity there here. So if I were cross multiplied, this would become squared. And then if I were to do 192.8 divided by 200, that would be 96.04. So bring the squared over to the other side. Right, then I would add 10.8. So it would be ln, if I were to do logarithm to bring the n exponent down, n ln 0.9, so do ln 10.8 divided by ln 0.9. So n would equal 22.99. So if I were to plug it back into either one to find x, I'll choose this one. Take my TVM, so 21.8 as the payment, 22.99 as the number of years, 10.9 as the interest rate, 0 as present value, compute future value. So I would get 1,957.78 would be, which would be closest to the answer C.